Hello everybody. So in this video, what we are going to do is we are going to study a very important concept, which is a kind of backbone for neural networks. It is back propagation, right? So what we saw in the last video, we saw how to train a perceptron, right? How to train a perceptron. So that means how to training means you have to find out the weights for like different for example, if you have something like this, you have these inputs and they are going into the summation cell, and then there is an activation function, right? So w1, w2, w3, and then you have your output here. So you wanted to know that what are the optimal values of w1, w2, w3. That was called the training. So this is what we have done in the last video, right? Now you see, now you connect what you want to do. I told you in the first video that what we are trying to do here in artificial intelligence is we are trying to mimic human brain, right? So for that, definitely one perceptron is not sufficient. So definitely one perceptron is not sufficient. So we have concept of multi-layer perceptron, which is nothing but artificial neural network itself. We call it as MLP. What we have here, we have an input layer. So you have an input layer, and then you have many hidden layers. They can be as many, like depending on what you are working on. So you have many hidden layers, and then you have an output layer. Okay, so this is your output layer. So the moment you have so many layers and each layer has so many perceptrons, so you have a number of weights which are to be optimized, right? And the method we discussed in the last video is not sufficient. Method we discussed in the last video for training a perceptron is not sufficient. Okay, so you see, for this particular thing, like how to train the multi-layer perceptron, there was a question which was baffling the scientists and the people working in the field for many years. Then there was a breakthrough paper in 1986 by David Rumelhart and others. Okay, so this was a it was a very big paper which was like published in Nature journal. So the title of the paper was Learning Representations back propagation errors. Okay, so they introduced this concept, they coined this term back propagation, which was till now we are using for training our multi-layer perceptron. So we are till date using this particular algorithm which was introduced in 1986. Okay, so we are still using this algorithm to train our multi-layer perceptrons, right? So now let us see what is back propagation. So now our aim is to see what is back propagation. Okay, but before actually introducing mathematically what is back propagation, I would like to tell you, I will like to discuss something. For example, suppose like the idea of back propagation is basically this one. Suppose, okay, so what is the idea? Suppose you are making some vegetable curry, right? You are making vegetable curry So what you are doing here, you are putting some amount of salt, some spices, okay, some oil, and then your vegetables, okay, some amounts you are putting, and then you have your final, bowl of curry, okay, hot and yummy. Okay, so you have your bowl of curry, right? But when you taste it, you didn't like it, right? It's not very tasty. Okay, so you are saying that it is too oily. The final dish is too oily. Okay, so what you are going to do the next day? Can you tell me what you are going to do the next day? So you are going to put less oil. So for example, here, suppose you were saying that I put like 5 ml of oil, right? So next day you are going to improve your recipe, and you maybe you come out with some figure like 3 ml of oil, 3 ml of oil. So how do you come up with this number? Because you as a human being has very sharp brain, so you by tasting the soup, the curry, you were able to figure out that okay, next time I have to put around 3 ml, right? So what you have done here, you have adjusted your quantity so that your final output is better. Similarly, if you have suppose you felt that it is less salty, so what you are going to do next time, suppose here the salt was like 1 spoon, so because it was less, so next time maybe you will put 2 spoons or 1.5 spoon, depending on how less salt was in your earlier version, right? And similarly, spices also same way, right? So you'll adjust your numbers, right? Okay, after tasting the curry, you will adjust your numbers. Next time you will make the curry, right? The same is the concept for back propagation. So what is the idea? Same is the idea for back propagation. So what is the idea? So what we will do, so you see what information you have. You have with you, what is the thing you have? Your data, right? So that means you know that corresponding to x1, the first data point, you already know the output, right? And then corresponding to the second data instance, you have your output. And then corresponding to mth data instant, you have your output, right? Okay, so you already have these to your favor. So what we are going to do, we are going to feed this first input in, feed it in your MLP, get your output, okay, predicted output from your MLP, but you already have this expected output. So you have your predicted output minus y1, so you have your kind of error, and then you will look at, okay, this was the mistake I made, and looking at this particular error, you will adjust your weights. Okay, you'll start with some random weights, and we'll see later on that there are techniques to actually initialize the weights also for an optimal process. So depending on this error, you are going to adjust your weights. Depending on the error, depending on this error, you are going to adjust your weights. Okay, so this is the idea which we'll mathematically discuss in the next video. Okay, and there is one last point I want to make in this video. So you will see in many books that because whenever you are doing machine learning or AI, you definitely are going to use some software, right? Some package you are going to use, and in whatever package or whatever programming language or whatever software you are using, you will have built-in, okay, inbuilt code for back propagation. Okay, so what you have to do, you have your MLP, you just feed it in your code. Suppose back propagation, let me call, this is the code name. You just feed your MLP and you'll get your optimal weights. Okay, so without knowing anything about what this back propagation is, you will actually you can actually work on your MLPs. You can actually construct your neural networks and actually do something productive with it, right? So that's okay. It's like you can for example, if you don't have any knowledge about car engine, right, but still you can be a very good driver. So you don't know a thing, you do not know a thing about a car engine, but still you can be a very good driver. Okay, but can you think of a problem in this process? The only problem is, suppose you are going in the night somewhere and your car is broke and you don't have any mechanic around. So at that time, so when your car engine is not working, so at that time you realize that it was good if I had some information about my engine. So the similar way, when your MLPs are not working according to what you were looking for, right? MLPs are not working according to your need. At that time you want, like, okay, there should be something I can do with my maybe back propagation process. So at that time it is very much required that you actually know what is back propagation, right? So what I'm trying to do is I'm trying to convince you that it is a worth it is a worth its time if you are giving for back propagation. So we'll be learning the mathematics of back propagation in the next video. Thank you.